everyone. So today we are doing word equations. Word equations are equations that represent a chemical reaction. And they do this using the names. They use names of all the substances involved. So this means that by looking at a word equation, I'll be able to tell all of the different compounds, the elements, the particles that played a role in carrying out the chemical reaction. All of the substances involved. Now, all your word equations make use of this pattern. Your reactants are always towards the left, and you would see an arrow stretching out of the reactant part, and they form your products that are always towards the right of the arrow. Please know that your word equations do not have an equals to sign. Instead of an equals to sign, there is an arrow which shows a progress of a chemical reaction. This shows that a chemical reaction has taken place and the reactants have reacted to form X, Y, Z products. Let's look at this. A plus B form product C. This means that A and B were the reactants. They were reacting together to make product C. This was the product that was formed as a result of the reaction, the chemical reaction between reactant A and reactant B. Let's discuss an example. Let's say that it's given to us that potassium hydroxide is going to react with sulfuric acid. Sulfuric acid, and as a result, potassium sulfate and water are formed. Now, how would we convert this into a word equation? They've told us that potassium hydroxide is reacting with sulfuric acid. Does this not help tell me that this is most probably a reactant? Because they've used the term reacts, right? So this tells me that potassium hydroxide and sulfuric acid most probably definitely are the reactants. And what are they forming? As a result, potassium sulfate and water are formed. So because they've used the term form, this tells me that this is the product. So if I was to form a word equation of this is what I would get. Potassium hydroxide being reactant 1 plus, with a plus sign. The other reactant is sulfuric acid. I'm going to put that here as well. They are going to form what? They form potassium sulfate plus water, because these two are the products. Similarly, let's look at some other example of word equations as well. Sodium. Here, the element sodium reacts with chlorine, and it forms sodium chloride. Here, then again, these two were our reactants. And what was the product in this situation? It was sodium chloride. This was our product. Please note that word equations are written in words, as in, word equations do not make use of chemical symbols or the elements or the chemical formulas. Okay? You need to stick to the names of the elements, the name of the compound, like sodium chloride, rather than saying NaCl, right? This is a word equation. This is a word equation, and if I was to write the chemical equation for this, I'm going to refer to the periodic table. The periodic table tells me that sodium, the chemical symbol for sodium is Na, and for chlorine it is Cl, and they're together going to form NaCl. the basic idea remains the same. These two are our reactants, and NaCl, this is our product. However, this is not a word equation. This is a chemical equation. So please know the difference. If the examiner asks for the word equation, you write the name of the element, the name of the compound in words. If the examiner asks for a chemical equation, you use the periodic table, you refer to the periodic table, and you figure out the chemical symbols and you write them down. Another example of a word equation, a very famous one, shows up multiple times in your past paper, is calcium carbonate. Breaking down to form sorry about that. So calcium carbonate breaking down to form calcium oxide plus carbon dioxide, right? Perfect. This is it about word equations. We're now moving on to chemical equations and their balancing, because balancing is one of the topics that students find really hard. So we are now moving on to chemical equations. What's the primary difference between chemical and word equations? Chemical equations make use of symbols from the periodic table, and your word equations make use of the name of the element or the compound. Now, it is very important to know some abbreviations before we get to the chemical equation part. There are some state symbols that you need to be familiar with and what they mean. You are going to come across symbols like this. This is carbon. Let's say this is, wait, H2, hydrogen, present in gas form, reacting with O, oxygen, also in gas form, forming H2O, water, in liquid form. Now this is just an example. Here, the state symbol S. There's a state symbol S that stands for solid. Wherever you see an S written in brackets like this with chemical equations, that means that that certain particular chemical is in a solid state. This tells me that here's a G, and I can also see an L. L stands for the liquid state. G stands for the gaseous state. This tells me the hydrogen and oxygen were in gaseous state when they reacted together to form water, H2O, in liquid form. And then there's this fourth chemical state symbol, that is AQ. That stands for aqueous solution. An aqueous solution is anything that's dissolved in water. It's not purely water, but anything that's dissolved in water. If I dissolved in water, anything that's dissolved in water is going to form an aqueous solution. For example, if I dissolve a tablespoon of salt in water, what is it going to form? It is going to form an aqueous solution because that's basically salt dissolved in water, right? But simple water, like pure water, I'm not going to call it aqueous solution. It's going to be in a liquid state. Unless and until I dissolve salt in it, then it would form an aqueous solution. So please be careful about the difference. Now, let's forget this example for a bit. It was just for explanation purposes. You should know that H2O can be present in a liquid state. H2O can also be present in a gaseous state. And H2O can also be present in a solid state. H2O liquid present as in a liquid form, that's the water that we drink. We wash our dishes with. We do the daily life chores with. H2O present as gas is steam. And H2O present in solid form is ice. This is something you need to know. This is important. Then you need to know HCl. HCl is basically HCl present in a gaseous form with the state symbol with a G enclosed in brackets. This is your hydrogen chloride gas. HCl in aqueous state is hydrochloric acid. I want you to memorize this. Super important. Very, very important. Both of these are very important. Now we are moving on to the concept of balancing chemical equations. Let me give a nice clear heading. Balancing equations. Okay, let's take the example that we took here. Na plus Cl forming NaCl. Now this is a relatively simpler example. Sodium reacting with chlorine to form NaCl. This is a chemical equation. Let me write down the word equation to simplify things for us. This is sodium. Sodium is reacting with chlorine and they are forming sodium chloride. Now, when it comes to balancing equations, it is important to make sure that there are equal number of elements on both sides of the equation. So there are equal number of all of these elements on both the left and the right hand side, both the reactant side and the product side. With this equation, we are very lucky because how many sodiums are there on the left hand side, on the reactant side? There's one sodium. Yes. How many chlorines are there on the reactant side? There's one chlorine. And if we compare that to this side as well, that also shows that there's one sodium and there's also just one chlorine. So this tells me that this equation is fully balanced and I've got no problem with this. This is the final version of this equation. Like, I cannot further balance it anyway. Let's take the example of a chemical equation that is not balanced. So you can so things become clear to you. Okay, so we've got nitrogen gas reacting with hydrogen gas to form NH3, right? What is NH3? Question. I made you draw a table in the other lesson. Look up your previous videos. You need to know this by heart. What is NH3? NH3 is ammonia. This is something you need to know by heart. NH3 is ammonia gas and NH4 is ammonium. Please don't confuse them. Ammonium and NH3 is ammonia gas. Okay? Now, let's look at the number of elements, number of particles of each of these elements and compare them to the amounts present on both the left and the right hand side. Let's look at the reactant side first. Let's look at the nitrogen element. How many particles of nitrogen are present on the left hand side? 2, because there's an N2 with it. So this tells me that there are 2 nitrogen atoms present. And how many are there for hydrogen? There are 2 for hydrogen. Let's compare it to what's going on the right hand side. There's just 1 nitrogen particle present and there are 3 of hydrogens present. Please don't make this mistake. Most of the students, what they do is they end up thinking that there is basically 3 of nitrogen and 3 of hydrogen. No, the 3 is with hydrogen. So there are 3 hydrogen particles with each nitrogen particle. If there was like a whole bracket around this and there was 2, then this would basically mean that there are 2 nitrogen and 6 hydrogens. Okay, but we don't have this 2 to confuse us, so this is the ratio that we have. How can we balance this out? 2 nitrogens, 2 hydrogens left hand side, 1 nitrogen, 3 hydrogens right hand side. How about we put a 2 next to this? If I put a 2 next to this, the amount of nitrogens present become 2, the amount of hydrogens present becomes 6. Yes? But that's like way more than what's going on here. But did my nitrogens not get balanced? Yes, they did. And that's good news. So the only thing that I need to do now is make sure that my hydrogens also get balanced. If I add a 3 next to the H2, would it not get balanced? Because now 3 times 2, there are 3 molecules of H2 now. That means that there are a total of 6 hydrogen particles. So this is how my equation got balanced. Yep. Let me make it easier for you. When there is H2, that means that there are 2 particles of H joined together that have formed a molecule. And if I say that this is 3H2, that means that there are 3 of these molecules, 3 of the H2 molecules. This is how I want you to visualize this. When I said that there's NH3, that means that there's 1 particle of nitrogen bonded to 3 of hydrogens. And this is what the situation looks like, right? If I add a 2 next to this, N2NH3, that means that there are 2 of these particles. There are 2 of N's, and each of the N is bonded to 3 hydrogen particles. Just like this, right? So this is how you end up balancing your equations.